folks, let's get into this example 1612. This is a big problem. This is a hard one, but we can do it. It's going to combine several different types of calculations we've been doing. So let's get into it. So a solution is prepared by adding 150 mils of a 1 times 10 minus 2 molar magnesium nitrate solution to 250 milliliters of a 0.1 molar sodium fluoride solution. How many grams of solid MgF2 will form? And then we also want to calculate the concentrations of magnesium 2 plus and fluoride in equilibrium with the solid. So basically, this is like doing our qualitative analysis, but quantitative, right? We want to know exactly how much of that precipitate we form and exactly how many of those ions are in solution in equilibrium with that precipitate. And I like to set up this calculation in kind of like combining two different ideas that we've used. Number one, a before and after table. Number two, a rice table. So let's write that down. We're going to say number one equals before after table calculation. And then number two, a rice table calculation. And I'm going to set this up to be this before after table calculation first. And I'm going to set it up as following. So we know that magnesium fluoride is our solid from our magnesium nitrate solution. We can see the nitrate doesn't matter, it's a spectator, and the sodium doesn't matter. So really we just want our net ionic equation from this thing. I'm going to give myself more room here by starting over here. So magnesium 2 plus 2F minus forms MgF2, and I'm going to put a number 1 over this reaction arrow to show the first calculation we're going to do is this before and after calculation, so we can just see how much of the solid we form in the first place. Okay, and we want to do that in number of moles. That's right, you guessed it. So I have 150 milliliters. Okay, so we'll set this up before. So I've got 150 milliliters, which is 0.1500 liters, times the concentration, 1.00 times 10 minus 2 moles per liter. So that's going to give me my moles right there. Now I also need to figure out my moles of fluoride. So that's going to be 0.2500 liters from my 250 milliliters times my 0.100 mole per liter. And let's do those calculations. So let's see, 0.15 times 1 times 10 to the minus 2 is the same as 0.0112, right? So from there, that's 1.5 millimoles. I'll just keep that in terms of regular moles, 0.0015, and then we're going to have 3 sig figs from this, from the concentration here. And so now let's calculate how much fluoride we have. So that's 0.25 times 0.1 equals, and so now this is 0.0250 moles. And we'll say that we have 0 of this to begin with. And now, as you can see, we've got a limiting reagent situation going on, right? I have over here a much larger excess of fluoride than I have over here. So all of my magnesium is going to react. And pay attention to the ratios, right? This is 1 to 2 to 1. So that means in my calculation here, all of this is going to react. If all of this reacts, then that means 2 times that amount has to react for fluorine, right? Because for every 1 mole of magnesium that reacts, we need 2 moles of fluoride that reacts. So now that's going to be minus 2 times 0.0150 moles. And that means over here, this is plus 0.00150 moles. So now if we look at our after situation and how much we have, we've got 0 moles of magnesium 2 plus now because it all reacted away. Over here, we have the 0.025 minus 0.003, right? Because it was 2 times that number. So that's going to be minus 0.003 to give me 0.0022 moles. Okay, 220 moles. And then now over here, of course, I just have 0.00150 moles. And so now the way that this is going to work, all right, we are now going to have a backwards calculation right here. And I'm going to represent that just by, showing the equilibrium arrow. And now this is calculation number 2. And what we're going to see here, a good kind of thing to think about, we have some amount of magnesium fluoride, a certain number of moles, that we can turn into a number of grams from the magnesium fluoride formula. Also, when we think about this, this looks just like the problem now that we did before, where we have some amount of fluoride in solution, and based on my KSP value, I can calculate how much magnesium I'm going to have in solution. Okay. So now what I need to do first is convert the fluoride into molarity. Okay. And we'll do that by dividing by our new volume, which is going to be the 0.1500 liters plus the 0.2500 liters, right? Because we combined those solutions. That's going to give me 0.4000 liters. Okay. And that's going to give me a molarity of fluoride. So now that becomes 0.022 divided by 0.4. And this gives me 0.055 molar. And now I'm going to put like another little line right here to tell us, like, signify we're doing a new calculation now. So this is now 0. And I'm going to write this kind of backwards, right? This is going to be let's see. I want that I to be on the other side of the line. So this is now my initial, we're going to have a change, and then we're going to have an equilibrium, okay? Assuming that I left myself enough room. So we don't care about this for the equilibrium concentration, but what we do recognize is for the end of this problem, I can convert this 0.0015 mole into grams. So we'll leave that aside for the time being. So then we also recognize that this magnesium is 0. This is going to have to be plus X, right? Which means this is also going to have to be plus 2X, okay? But because we have such a large excess of fluoride and we expect the value of X to be small, we're just going to assume that this is going to be approximately 0.055 molar at equilibrium, right? We're not going to worry about the 2X. So you can see that this is actually not so bad. Of course, I just ran out of room for doing this calculation. So what I'm going to do now is say, okay, up here now for my final calculation, it's going to be KSP equals this value of X times this value right over here, 0.055 molar, all squared. So now I just want to simply solve for X. So X equals my KSP value, which is 6.4 times 10 minus 9, all divided by 0.055 squared. So let's do that. So let's see, 6.4 times 10 to the minus 9 divided by 0.055 squared equals, and as you can see, we got a really small value for X, which is going to be my molar solubility. So I'm sorry I ran out of room, folks, to write here. I'm going to erase this stuff here because I recognize that I could have really used that space there. So there's my R, here's my I, C, E. So now we know that this is my value of X, which is my molar solubility. So I'll say to, let's see, we needed, I suppose that would have been 3 sig figs. So let's see, 2.12. 2.12 times 10 to the 1, 2, 3, 4, 5, 6 to the minus 6 molar. And so what is all that going to mean? Well, calculate the concentrations of magnesium 2 plus and F minus at equilibrium. So there it is. That's my magnesium 2 plus equilibrium. My fluoride, I already calculated, it's 0.055, and technically it's 0.055 plus 2x, but we know that that's going to be really, really small. So we know that my fluoride is just going to be 0.055 molar. Okay, and how many grams of magnesium fluoride will I have? Well, now I need to take this 0.0015 moles and turn it into grams by using the magnesium fluoride molar mass. And of course, I don't have a periodic table in front of me on the slides, but I have one right here. So let's take a look. So magnesium is 24.3. So that's 24.30 plus 2 fluorines. Each one is 19.00. So I'll just say plus 19 equals. So this is 62.3 grams. And so now if I multiply that by 0.0015, here you can see now I get 0.0935 grams of magnesium fluoride. And there are all of my final answers. So if I just wrap this up, again, if I summarize how this calculation went down, we first started with a before-after table by just assuming all the magnesium reacts with some of the fluoride because the magnesium was the limiting reagent and all of it gets consumed. Okay, and so that makes some amount of magnesium fluoride. And technically speaking, right, some of this has to dissolve to make back more magnesium, right? We didn't even include that in this calculation, right? We started with 0 magnesium because it all reacted, and then now this goes back to make 2.2 times 10 minus 6 molar. Where is that coming from? Well, it's technically coming from this, but we're assuming that's such a small amount that this is our final amount of magnesium fluoride we're making. Okay, so that's really tricky. So make sure that you understand that. Okay, so we get some amount of magnesium fluoride, and we're going to assume that's our final amount because not a whole lot of it's going to dissolve. So then our second part, we do a rice table, and we recognize that we have an abundance of fluoride left over, and that is likely now meaning our solution is saturated in fluoride. We're not going to really be able to add any more to it. So that gives me my equilibrium fluoride concentration, and then we just simply solved for X or S, whatever letter you prefer, and that gives me my magnesium concentration. Okay, so these are really hard problems, so make sure that you can do this and that you followed along. Okay, folks, one last learning goal for this entire chapter.